Okay, so the question is saying, let's just jump in. I'll be just writing here. So K is equal to, because now if I keep on shaking this thing, it will be a mess. So we have 9x and x. So we have been given this matrix, right? This matrix saying K is equal to 8, 1, 9x and x. So it's saying that find the value of x for which the determinant of K is 2. So the determinant of this K is equal to 2. So they want us to find that value of x. So now how do we get to find that value of x? So like I said, my good friend, the phone is on charge, it's at 0%, so I don't want to disturb it because I need the questions from that Kasem app. So how we can find now the value of that x? We get to find it like we are solving for determinant. I hope you guys are able to see, right? Let me try to take it down here. All right, we get to solve it like we are finding for determinant. So we are going to say multiplication of the major diagonal. This is what we call major diagonal, like this. So the multiplication of that minus the multiplication of that. So it will be 8 times x, which is 8x, right? 8x. Then it's a minus 1 times 9x, we get 9x, is equal to the determinant. Because this multiplication of the major diagonal minus the multiplication of the minor diagonal, we do that when finding the determinant. So if determinant has already been given, we get to equate to 2. So we say 8x minus 9x, we get negative x is equal to 2. This is not it. We get now to divide both sides by negative 1 because the coefficient of that x is negative 1. So that the negative can go, or negative divided by negative is positive. So now we got x is equal to 2 divided by negative 1 is negative 2. So this is the value of x that they're asking us to find. All right. So that's the value of x that they're asking us to find. So paper 2 questions, they ask you to find the value of a missing variable. It can be p, it can be x, like the way it is. Then next, now they get to ask you to find the inverse. All right, so in this, now they're asking us to find the inverse of k. So for us to find the inverse of k, we are going to first come up with the same matrix that were given. But now this time around, where there is x, we put negative 2. So it will be 8, 1, then say 9 times negative 2, because where there is x, we are putting negative 2. So 9 times negative 2 is negative 18. Then where there is x, we put negative 2. After that, now we can find the inverse. How do we get to find the inverse? We say the inverse of k is equal to 1 over determinant multiplied by the adjoint of that same matrix. So the inverse, the determinant we know is 2, because 2 was given. But we don't know the adjoint. So we get to find the adjoint. So how do we get to find the adjoint? We'll say the adjoint of k, all right, is equal to, right? So the major diagonal, they interchange the position, meaning that negative 2 will go up where 8 is. So we have negative 2 and 8 will come down here. Then for the minor diagonal, the sign are the one that changes. So like the way this one is positive 1, it becomes negative 1. And the way that one is negative 18, it becomes positive 18. That's how you get to find the adjoint. After we find the adjoint, my good friend, we come back to this now. We say the inverse of matrix K is equal to 1 over, what is our determinant? Determinant is 2. Multiplied by the adjoint, which is negative 2, negative 1, 18, 8. Most people get to leave their answer right here saying that's it. No, this is not it. All right. So what we are going to do now is we get to multiply half by everything. So since our numerator is always 1, what that means is that we just get off, we just put over our denominator over our denominator over our denominator throughout. So to be negative 2 over 2. All right. Then say 18 over 2. Then we have negative 1 over 2. Then we have 8 over 2, just like that. So now in simplifying our work, we'll say negative 2 divided by 2 is negative 1. Then negative 1 over 2 is negative half, like the way it is. Then 18 divided by 2 is 9. Then 8 divided by 2 is 4. This is now the inverse they're asking us to find. That's the inverse.